All right, guys, welcome to the Law of Sines Part 1. Okay, so we've been studying a lot of trigonometry, and we've studied right triangle trigonometry, but what the law of sines and later on the law of cosines will tell us is that we can use these rules or these laws to help us solve triangles that are not right. Okay, so use the law of sines to solve oblique triangles, okay? So, and when we mean solve, we mean find missing angle measures and missing side lengths, so all of that. Okay, so that's what we mean when we say solve a triangle. Find all the missing pieces you can. Now, there's two cases when we use law of sines, okay? And where they're for angles, angle, side, and angle, side, angle. You should be familiar with that from geometry. The other one is when you have two opposite sides, or two sides and one angle opposite one of these sides. That's called side angle. That's going to be in video 2. This is called the ambiguous case. So there's some things that can happen on this, so we have to devote a special video for that. So let's take a look on the definition of the law of sines. Okay, so here it is. If triangle ABC, if ABC is a triangle with sides A, B, and C, then the following ratios are equivalent. A over sine A equals B over sine B equals C over sine B. Little a, B, and C are the side lengths. The big A, big B, big C are the angle measures, okay? Alternatively, if you flip each one of these, take the reciprocal, it's the same definition. So be aware these are the two definitions that we use. In each video I use the top one though, okay? But there is an alternative form for that. So let's solve some triangles, okay? So example 1, if C is 102 degrees, 0.3 degrees, B is 28.7 degrees, and B equals 27.4 feet, find the missing angles and sides. So we have to solve everything. Now, this example, we have two angles and a side. Okay, so we've drawn the figure here, and notice across from the angles A, across from B is B, and across from C is C. Okay, so here's my figure. Now, the easiest thing to do is find the angle first, because I already have two angles. Okay, so let's look at this. So we have angle A is equal to 180 degrees minus the sum of angles B and C, right? 180 degrees makes up a triangle, the sum. Okay, so 180 degrees minus, I substitute my two angles in, and I subtract from 180, and I get A is to be 49. Boom, done with the angles. So I've got all three angles. Now I've got to use the law of sines to find the two missing sides that I need, sides A and C. So how do I do that? Well, if I want A, I better use A. So I have by the law of sines, A over sine of A, which was 49 degrees, equals B over sine B. Now I want to be careful. I chose this ratio because I knew both the side and the angle. It wouldn't be good here to use C over sine of C because I don't know either of those pieces. Well, I just know the angle. So I've got to know one of these ratios, I have to know both pieces. So I set up my ratio, and I'm going to solve for A. So you see the arrows there, cross multiply. So we have A times the sine of 28.7 equals 27.4 times sine of 49. We solve for A by dividing each side by sine of 28.7, which is what you see here. And when I divide all this out, I get 43.061. So try to make sure you round to 3 decimal places because you're going to need to do that when you get into calculus. So that's the missing side length of A. Now I've got to find C. Now I know the angle for C, I just don't know the side length of C. So I set up this ratio. I use B because those were the given values. It's not an estimate like the side of angle A was. So I use I take what I've been given for B, and here's sine of B. So here's my law of sines ratio. Okay, I plug in by substitution, so I plug in my known values for everything. Notice I just have a C that's unknown. That's really good. And so I cross multiply, okay, because they're proportions, ratios, okay. So it's a proportion, two ratios equaling, and then I get 27.4 times sine of 102.3 degrees equals C times the sine of 28.7 degrees. Okay, I solve for C by dividing each side by 28.7. Okay, so I get C is equal to 55.747 feet approximately. Okay, so now I have solved the triangle. I have all three sides and I have all three angles. I'm done with this problem. in example 2, we're given something a little bit different, okay? So we still have two angles and a side, okay? But this is that angle, side, angle example. So here's my triangle, okay? Again, I've been given an angle of 50, an angle of 33.5, and B equals 76. Solve the triangle. So again, that means find the missing angles, find the missing sides. Now, I have two angles, so let's find the missing angle first. B. So I have A and C angles, so I know that B is equal to the difference of 180 minus A plus C. There's the substitution of my two angles. I subtract that from 180, so I get my C angle to be, or not my C angle, I'm sorry, my B angle to be 96.5 degrees, okay? So now I got to go and find my missing sides. So when I do this, I set up a ratio. Now let's see what I have. I have A, just one thing for A, okay? But now I have B angle and B side. So that's the known ratio I'm going to use right there. I'm going to find my missing side length for A. So there's the ratio of law of sines. And I go ahead and substitute my three pieces in that I know. I cross multiply. That's why you see that red X there. So I get A times the sine of 96.5 equals 76 sine of 50. 76 times the sine of 50. And then I go ahead and divide each side by sine of 96.5, and I get 58.596 feet. So that's the side length for A. Okay, I said feet, it's units, they didn't tell me, so 58 units. So let's find that missing part of C now. Again, there's my ratio. We'll just set those down, sorry. There's my ratio of C over sine C equals B over sine B. So there's the law of sines. And again, by substitution, I plug in everything I know, and then I go ahead and cross multiply. So I get C times sine of 96.5 equals 76 times the sine of 33.5. To solve for C, I divide each side by 96.5, sine of 96.5. And I end up with 42.29 feet when I divide that out. So that's the first video on the law of sines. We're not going to do the ambiguous case until the next video. If you guys have any questions or comments, let me know. We'll see you next time.